Good afternoon, everyone. As Scott mentioned, I will be describing two different case examples using paint and tape databases that we have available to us at the FBI laboratory. We have multiple databases within the paints and polymer subunit and also a variety of sample collections to provide investigative leads to investigators. We have a duct tape collection, which I will describe today by using one particular case example, that we have all of this information archived in a database called Slice, which I will give you some descriptions on. And then I will also discuss an automotive paint make, model, year search in which we utilize the paint data query database. So for the duct tape case, this was a homicide in which the victim had been wrapped in trash bags with duct tape around the trash bags. And we were asked to attempt to determine the manufacturer of the tape. Now, in our analysis, we first begin with the visual and microscopic examinations. These include examining the backing and adhesive for their color, looking at the backing appearance to see if there are any manufacturing markings on them, evaluating the backing layer structure microscopically, looking at the width and the thickness, as well as a variety of different fabric characteristics. Within the chemistry unit, we do a general analysis of the fabric in the tape, looking at the scrim count, the weave, and the general construction. However, following the rest of the examinations, we will then transfer the items down to the trace evidence unit, where the hair and fiber personnel in that unit will do further analyses. So this is just three different pictures of the types of weave to give you an example of the variety of materials that we might see within a duct tape. Following our visual and microscopic exams, we then perform FTIR analysis, in which we are first off looking at the adhesive chemistry by micro FTIR. This provides us with some organic as well as some inorganic information for our tape adhesive. We will also use ATR analysis to evaluate the backing chemistry, but more importantly, we're looking at the layer structure and we're evaluating it by this technique. We had a publication in January of this year in Forensic Science Communications that describes this in more detail. So following that IR analysis, we then perform XRD analysis, in which we're looking at the crystalline information. We're analyzing the duct tape intact. Occasionally, we will analyze the backing alone. Following that, we will perform SEM EDS analysis, in which we're getting the elemental information for both the adhesives and the backings. In general, the XRD or the SEM EDS analysis, sometimes they're mixed up. This was historically because we had a different examiner doing the SEM analysis for us. XRD is generally a little bit faster of a technique, so we'll do that first, but it's really not important either way. Now we'll do this whole analytical scheme, whether we're doing a comparative analysis or in this case an identification analysis, but when we're trying to do an ident, we're then going to perform searches in the Slice database to try to determine the manufacturer of the tape. So the duct tape collection that we have, at the time of this case, there was just over 80 tapes within the collection. However, it has now been expanded to include information for over approximately 400. These tapes have been acquired by FBI personnel, purchased at common retail stores, or obtained from manufacturing site visits that we have gone on. Most of them are marketed as general purpose or economy grade, and they cover a wide range of manufacturers. Here's the information that I promised you about the Slice. This stands for Spectral Library Identification and Classification Explorer. It is an archival program which primarily stores EDS data, but there are a variety of data entry capabilities in there that allow us to have modified the traditional database to be able to put the different physical and chemical characteristics of our duct tapes in there as well, so that we can search all of them together. And this was developed through a collaboration between the FBI, the FDLE, and the Missouri State Highway Patrol. So back to the case, the full protocol was completed, and I noted that there were a few relatively unique physical characteristics. The first was that we were dealing with a multi-layered backing. Now what this image is showing is this is the edge of the backing as well as this. So this is the full cross-section thickness of the backing. And we see we have a clear colorless layer at the top as well as the silver layer there underneath that. I also found that there were texturized yarns in the warp and fill directions of the fabric, and this was more unusual than some of the other tapes that we have seen. And I also knew that there were a limited number of these types of tape in our database. However, the chemical composition of the tape was relatively common. So this is the main window for the SLICE database, and this is the EDS spectrum here of the adhesive for this particular sample. On the bottom left-hand side is a listing of all the different materials that are in the database. We have pictures that we can also include with each EDS spectrum in order to pull those up as a first look at the physical characteristics of the tape, as opposed to pulling the sample out or looking at the data entry, which we have over here, which allows us to put the analyst information, the laboratory, in the instances that we have multiple laboratories contributing to the database. That's where we can put the variety of physical characteristics of the backing, the adhesive, as well as the scrim, and also some analytical conditions that they were all collected at. There's also a notes tab that allows us to put pretty much any type of text-based information that we would like to include along with the EDS data. So I gathered my sample and got the EDS spectrum from the adhesive, and then I performed a search of our database in an attempt to determine a reference sample to compare it to. So I searched by best fit, which means that it was going to search my spectrum to figure out which spectra within the database had the best correlation to my particular sample, and then it ranks them according to their EDS spectra. I also searched a few physical properties. In this particular case, I looked at the scrim count with the addition of one yarn in either direction, on plus or minus one in either direction of the tape, and also looked at the scrim weave, which was plain weave. And then I chose to just search the duct tape adhesive, since we knew that that's what we were dealing with. Based on all that information, there were 3 tapes in the database that met those criteria, and then SLICE ranked them according to the best fit of their adhesive. These tapes are identified as CT282, CT281, and CT283 in that order by best fit. And as you can see, the adhesive spectra are very comparable. The information for these 3 items, this is just a few of the physical characteristics that are in SLICE to show that they are physically consistent. And you'll also note that they're all manufactured by the same manufacturer, which was 3M. I did a similar search, but a completely separate search on the backing EDS spectrum, and again got the same 3 hits because I was looking at the same physical characteristics, and then it ranked them by best fit, again with CT282 being the best fit. And you'll see that the ratio of aluminum to silicon in that tape more closely resembles that of my reference sample, or my casework sample, as opposed to the other 2 in there, and I will be able to further explain that in a moment. This, if you'll remember, was the layer structure of my question sample, and it's also the layer structure of that CT282 sample, which was the best fit in both searches that I had performed. The other 2 had an additional 3rd layer in here, which was another clear, colorless layer on it that may or may not have been here in the casework sample as well as the other reference sample. However, the thickness of that, if there is in fact a layer there, would be much thinner. Now, the reason why in the EDS spectra we were seeing the difference in the aluminum-silicon ratio is because when we performed the EDS analysis on the backing, we actually had the beam of the SEM hitting this portion of the sample. So since there's a thinner colorless layer there, it had easier access to that aluminum-silver layer that resulted in the increased level of aluminum compared to the silicon. Now, the final candidate, the CT282, could not be eliminated following comparison of all of the data that had been collected on that through the variety of techniques that we use when we compared that to our casework sample. We contacted multiple industry representatives, not really telling them that we had a pretty good idea of who it was. We contacted 3M, SureTape, and Tyco, which is now Covalence, and asked them, given these physical characteristics, do you have any indication of who might have made this product? And it was confirmed that this tape was a 3M product, as we had suspected. It It was a home and shop product, which is also marketed as 3M Duct Tape 3900. It's a general purpose tape manufactured by 3M in Canada. However, laboratory examination does not allow us to determine the distributor of a tape sample for a variety of reasons. So this information we were able to provide to the contributor for those investigative lead purposes. So now, moving on to the automotive paint case, we had a hit and run in which the victim was struck and killed by an unknown vehicle while lying on the road. As with most make, model, year cases, we were asked to examine the victim's clothing, and there had also been vehicle parts found at the scene to provide any possible vehicle information that we could find. After processing the victim's clothing, I noted that there were 3 different paint systems encountered amongst the victim's clothing as well as the debris. There was a white, non-metallic set of paint chips found within the victim's clothing, and there was also a light-colored metallic paint chip set of paint chips found within the victim's clothing. Furthermore, the plastic parts had silver metallic paint on some of them, and those had been left at the scene. So that first system, this is the white non-metallic layer, we performed microscopic examination, FTIR, and SEM EDS analysis on our paint chips. And then I performed spectral searches using PDQ on the 2 primer layers at the bottom. We had 4 candidates following these spectral comparisons of the 2 primer layers that we searched, but then also pulling up the spectra from the clear coat layer on the top and did a direct comparison. And all of these were from General Motors vehicles from the Flint, Michigan plant manufactured in the 1994 through 1995 model year range. For the second paint system, I mentioned this was a light-colored metallic paint. The color coat was very sporadic across the layer, which made color determination very difficult. We could see or I could see the primer layer through the clear coat. And when I first looked at it before I did my cross sections, I thought I was looking at a sporadic zinc phosphate layer on the bottom of a primer layer. However, further looking at the cross section as well as chemical analysis indicated that that was in fact a color layer. It just wasn't applied very well. I don't know if it was maybe on an undercarriage part of a vehicle that might not have gotten adequate paint coverage. The reasonable hits following comparison of all of these layers included 4 samples from the Lordstown, Ohio plant from the model year 2000, and then 1 each from Lordstown in 2002, Oshawa in 2001 and 2005, and then a Missouri plant in 2000. For the third paint system, or the paint that was on the plastic, this was again a silver metallic paint on top of a plastic part. There were no primer layers in this particular sample. Again, performed the microscopic IR and SEM analysis, and then performed a spectral search on that clear coat layer. However, the make, model, year searches were unsuccessful. So at this point, since I found paint from at least 2 different vehicles, I contacted the contributor because I was curious and wanted more information. I didn't know whether it had been a busy intersection and maybe this gentleman had unfortunately fallen on paint that was already on the road, or whether 2 vehicles possibly could involved. But then the contributor said, oh yeah, I guess I didn't tell you. The victim's vehicle had actually rolled over him before the hit and run incident occurred. He had lost control on the road, somehow was thrown out of his vehicle. His vehicle ran over him, and then car coming on the oncoming lane of traffic ran over him. The car that he had been driving was actually a white 1994 GM van that was manufactured in Flint, Michigan, based on the VIN number, which we had already determined this pretty much based on our PDQ searches. So unlike in most cases where we provide this information and we never hear back what happens or whether our identification was in fact correct, in this particular case, we now have a perfect example of how PDQ actually works. So I didn't conduct any subsequent examinations on this paint system. So for that paint system B, if you'll remember, there were 8 PDQ hits that I had, 5 of them from different plant year combinations. I performed microscopic examinations on these. There were multiple paint samples that I have at the FBI. We have a collection of all of those that the PDQ contributors send to that we have available to us that we can pull out. And if at any point you all are doing a make model year search as well and want to do a direct comparison, please do not hesitate to contact us and we'll send you whatever we have. The same with the RCMP. There were a couple of my hits that I did not have available to me. They were Canadian samples, but I contacted Denis, and within a matter of days they were sitting on my desk waiting for me to analyze. These microscopic comparisons eliminated 2 of the plant years, which left Oshawa in 2005, Lordstown in 2000, and also in 2002. So on these samples, I performed FTIR analysis and EDS analysis on these remaining candidates to compare the data directly to my sample. For the Oshawa paint sample, I noted that there were slight color differences of the primers relative to my question sample. These are 2 light micrographs of the embedded cross-section of the paint chip that shows the layer structure. And it's more apparent when you're actually looking at it under the microscope, but there is a slight color difference of the top primer over the bottom primer compared to the reference sample that I had. However, at this point, I didn't feel like this was enough of a difference to eliminate this particular sample from my list of possible reference samples that compared favorably to my sample. I also noted a slight peak width difference at 1550 wave numbers of the OT2 layers, but again, I didn't feel yet that this was enough justification to eliminate this reference sample. However, once I did the EDS analysis, I did note additional elemental differences of the clear coat layers. And these are the EDS spectra showing the database sample at the top. It's got zinc present, a little bit of chlorine, and some phosphorus that the question sample did not have. So to make sure that I was eliminating this particular plant for the right reasons, I performed a PDQ search on other sample, or looking for other samples originating from the Oshawa plant, but all of these were eliminated, so I felt it was safe to eliminate this plant in this model year from my searches. Focusing on the Lordstown samples, these are 2 hits from the same plant, but different model years. The relative colors of their primers were consistent with each other and also with my question sample. The IR spectra were also consistent, so I continued on with the SEM analysis. Again, these are 3 overlays that I have generated, or 1 overlay of the 3 samples. And we have the Lordstown 2000 on the top, 2002 on the bottom, with the question sample in the middle. And the only difference that I noted was that the Lordstown 2000 sample had lead present. So I contacted our representatives at Lordstown for additional information on this. And they confirmed that model year 2000 was the last year that this plant used lead-based primers, and that the next formulation change at their plant did not occur until model year 2006, when the vehicles there, they switched what vehicles that they were producing at that plant. So the Lordstown 2002 sample couldn't be eliminated following all of the exams. However, as I noted, with the condition of the color coat, an accurate color evaluation could not be conducted. I contacted Lordstown again at this point to confirm that there had been no 2-tone vehicles produced at this plant, so that I could use those plastic parts in order to do my color evaluation on my question sample. So using information on the colors that the Lordstown contact said were produced on their vehicles during the model year 2001 through 2005 timeframe, I conducted color comparisons on my question sample to the repaint pages that we have available to us. And the question sample was consistent, or the color, with a GM silver metallic paint code of 8867. This has a variety of names, which include ultra silver metallic and silver effect. So we were able to construct a partial VIN on the automotive, on the vehicle, from the information that it was a GM vehicle manufactured in Lordstown, Ohio, sometime between 2001 and 2005 model years. And during that time, Lordstown was producing the Chevrolet Cavalier and the Pontiac Sunfire. Thank you.